Algebra 2. So this is for Quad 5, and we'll also have Quad 6, so 2 days worth of lessons in this one video. So just make sure you are on the same lesson that we are doing in class if you're watching it. If not, you're just doing it at home. All right. When you're using the graphing calculator, there's an awful lot that your calculator can do. So just go into Y1, look at the transformations of what's taking place with it. So this first one, this is the parent. So it's not doing anything different. This goes down. It shifts down. It doesn't open down. This shifts right. This shifts left 6 and up 1. And so we're going to go through these and take a look. So as I said, this is called the parent function. So if you do this, first one, x squared, you have a vertex right here at 0, 0. And you're going to go right 1 up 1, left 1 up 1, right 1 up 3, left 1 up 3, so on and so forth. And there's your parent parabola. This one shifts down, so this has a vertex of 0, -4, so you come down here, and then you still pattern graph because out in front of the x is just a 1, so right 1 up 1, left 1 up 1, right 1 up 3, left 1 up 3, and then it goes up 5 as well, but it's plenty to go with. And when we look at this one, it's going to shift right. So if it's a minus, it goes opposite the direction you would think. So our vertex is going to be at 0. It was a negative up there, right? I can't see it now. Zero, +5. So I'm going to go right 5, put a dot, pattern graph, right 1 up 1, left 1 up 1, right 1 up 3, left 1 up 3, so on and so forth. There's our parabola. This one is going to shift left 6. Actually, I made a mistake on this one. This vertex is 5, 0, not that. This one's going to be -6, 1. It shifts left because it's negative. Because you got a positive on the 6, and then up 1. Then pattern graph, right 1 up 1, left 1 up 1, right 1 up 3, left 1 up 3, so on and so forth. So again, this is our parent function. It just comes here. We go right 1 up 1, left 1 up 1, so on and so forth. Our vertex is 0, 0. This one, our vertex is still going to be 0, 0, but it's going to go right 1 up 2, left 1 up 2. And again, we use the 1, 3, 5 rule, so we'd multiply all of these by 2. So then I'd go right 1 up 6, left 1 up 6, so on and so forth. This one still has a vertex of 0, 0, but it's not going to, if we multiply 1 by 1, 3, we multiplied this by 1/3. Well, this one's kind of hard, so if we go 2 over, we're going to go up 1. So I'm going to go right 2, up 1, left 2, up 1, so on and so forth. So this is a nice fat parabola. The fraction out front, if it's between 0 and 1, makes it fatter. This one still has a vertex of 0, 0, but because you have a negative out front, it's going to go down. So your pattern graph is going to be 1, 3, 5, but we're going to go down. So right 1 down, 1 left, 1 down, 1 right, 1 down, 3, left 1 down, 3, so on and so forth. So in the equation that's given, the quadratic equation, this is called vertex form. Okay. And we'll just do these. All right. So the first thing is our vertex opposite of this, same as this. Axis of symmetry is always the x component of the vertex. And then the y-intercept, we plugged 0 in here for the x. So that's going to give you -3 squared. -3 squared is 9. 9 minus 5 is 4. The domain is still going to be negative to positive infinity. This opens up. So it's going to be the y component of the vertex to infinity. And transformations, it did some stuff. We're not going to really worry about filling out the graph because we can just pattern graph based on this. So 3, -5. 1, 2, 3, down 5. It's down here. Out in front, we're going to pattern graph using 1, 3, 5 in front of the x squared, or in front of the parentheses is not a number, so I'm going to go right 1 up 1, left 1 up 1, right 1 up 3, left 1 up 3, so on and so forth. And there's our parabola. We could have our y-intercept up here, but we've shown enough of the graph. All right, the vertex on this one is going to be opposite of this, so -1, same as this. 6, axis of symmetry is going to be at x equals -1. The y-intercept, I'll plug 0 in. 0 plus 1 is 1. 1 squared is 1. 1 times -2 is -2. -2 plus 6 is 4. The domain, again, is going to go negative to positive infinity. This opens down, so it's going to go from negative infinity to the y component of the vertex, square bracket. All right, so let's go ahead and graph this. So I get -1, 6. If we pattern graph, it's going to be 1, 3, 5 times -2. So I'm going to go right 1 down 2, left 1 down 2, right 1 down 6, left 1 down 6, and there's our parabola. Okay, so it shifted right and up 6, and it flipped over, and it grew at a scale factor twice as much. All right, so this is your worksheet. If you just copy this down, that means you don't really know it. But so the vertex is going to be -3, -1, so opposite of this, same as this. Our axis of symmetry is going to be x equals 3. Our y-intercept, if we plug 0 in, 0 plus 3 is 3. 3 squared is 9. 9 minus 1 is 8. So this one opens up, so I'm going to go -3, down 1. Our pattern graph is still going to be the 1, 3, 5. So if I go right 1, up 1, left 1, up 1, those found us x-intercepts, which is great. So we're going to have -2, 0, and 1, 2, 3, and -4, 0. Domain, again, is going to be negative positive infinity. This opens up. So it's going to be the x component, or the y component of our vertex. So that's going to go from -1 to infinity. And here's our parabola. This one is going to have a vertex at -4, +5. The axis of symmetry is the x component of the vertex. The y-intercept, we plug 0 in. 0 plus 4 is 4. 4 squared is 16. That's a negative, so that's -16. -16 plus 5 is -11. And so let's go ahead and graph this. Our pattern graph is going to be based on 1, 3, 5, or multiply by -1, so it's opening down. So I have -4. So -1, 2, 3, 4, up 5. So I'm going to go right 1, down 1, left 1, down 1. From there, I'm going to go right 1, down 3, left 1, down 3. And the thing is, it does indeed cross the x-axis, but we don't know. These are, remember the quadratic formula? The quadratic formula is basically going to give us weird answers like, square, or 5 plus or minus square root of 2 over 7 or something like that. That's what these answers would be, so we're not having to solve that in this case. Our range is going to go from negative infinity, because it's opening down, to the y component of the vertex. So that's going to be to 5, square bracket. So where did this move? It flipped over the x-axis. It shifted left 4 and up 5. For this one, it's going to be opposite of here. So 3, same as this. 3, -1. So 1, 2, 3, up 1. Our axis of symmetry is going to be x equals 3. Our y-intercept plugs 0 in, so 0 minus 3 is negative 3. Negative 3 squared is 9. 9 times negative 2 is negative 18. Negative 18 plus 1 is negative 19, so that's going to be way off there. Let's go ahead and pattern graph. So our pattern graph is going to be using the 1, 3, 5. We're going to multiply by negative 2. So I'm going to go right one down 2, left one down 2, right one down 6, left one down 6, so on and so forth. So again, it's crossing the x-axis, but again, it didn't have exact dots on there. The domain will be negative, positive, infinity. The range will go from negative infinity up to the y component of the vertex. So this did a right shift and a down shift, and it flipped over the x-axis, grew by a scale factor of negative 2. This one we have a vertex of negative 1, negative 10, so opposite and same. That's a 10. All right, so negative 1, negative 10 is way down here. Our pattern, our axis of symmetry is going to be negative 1. Our y-intercept, we plug 0 in. 0 plus 1 is 1. 1 squared is 1. 1 times 3 is 3. 3 minus 10 is negative 7. And then we can go ahead and start pattern graphing. So our 1, 3, 5 is going to be multiplied by 3. So I'm going to go right 1 up 3. 1, 2, 3. Left 1 up 3. And then I'm going to go up 9. So right 1 up 9. 9. Left 1 up 9. So there's our parabola. Our solutions to this, they do cross the x-axis, but you'd have to use a quadratic formula on it. So domain negative, positive, infinity. Our range is going to go from the y component of the vertex, square bracket, to infinity. Problem number 5, our vertex will be opposite and same. Our axis of symmetry is x equals 4. Our y-intercept will be 0, and 0 minus 4 is negative 4. Negative 4 squared is 16. Half of 16 is 8. 8 plus 5 is 13. So I'm going to have 4 comma 5. 1, 2, 3, 4, 5. 4, 5. Our pattern graph, we're going to use the 1, 3, 5, but we're going to multiply by half. So right 1 up half, left 1 up half, right 1 up 1.5, left 1 up 1.5, so on and so forth. So we're going to get through there. Domain is negative to positive infinity. Our range is going to go from the y component of the vertex to infinity. All right, so this one you can just work on. Take a watch what your teacher does on this one, and then convert these to standard form. Okay, meaning I don't want to have parentheses, so I'll just do the first one. This is 3x plus 1, x plus 1, minus 10. Foil this, that gives you x squared plus 2x plus 1. You multiply that by 3, so that becomes 3x squared plus 6x plus 3 minus 10 minus 7. That's yours on the first one. Let's take a look at our notes at quad 6. Quad 6, first thing we want to do is we want to convert from vertex form to standard form. So I'm going to multiply this. So I'm going to FOIL this out. All right, so we want to FOIL this out. So that's going to give me x squared plus 3x plus 3x plus 6x. 3 times 3 is 9. I'm going to multiply that all by 2 and then minus 1. Distribute the 2 over. So that's going to give me 2x squared plus 12x plus 18 and then minus 1. 18 minus 1. 18 minus 1 is 17. Okay, you do the same thing with this one. You just have to distribute a negative over, same idea. All right, so we want to graph each parabola in standard form. So we have to know that we have, if we come back up here, let's take a look. The big thing is you have an a in front of the x squared, a b in front of the x, and a c that it doesn't have the x attached to it. So that's going to relate to this equation here. All right, so My A is 1, my B is 4, my C is 1. So my axis of symmetry is going to be negative 4 over 2 times 1, which comes out to just negative 2. Okay, that's great. Negative 2 I'm going to plug in to get my rest of my vertex. So negative 2 squared is 4. 4 times negative 2 is negative 8 plus 1. 4 minus 8 is negative 4. Negative 4 plus 1 is negative 3. And our y-intercept is, when it's in standard form, it's just going to be that. Symmetric point, we'll hit this in a moment. Domain we know is going to go from negative to positive infinity. The range is going to be the y component of the vertex, square bracket to infinity because it opens up. So let's go ahead and graph this. So I have negative 2, negative 3. My pattern graph is still going to be the same with 1, 3, 5. So I'm going to go right 1, up 1, left 1, up 1, right 1, up 3. Oops, did I do that right? Let's see. Negative 2, negative 3, right 1, up 1, right 1, up 3. Oh, here's my symmetric point. Remember, so the y-intercept is right here. So the symmetric point is going to be 1, 2, 3, 4, negative 4. So it looks like that. All right, again, we're going to use negative b over 2a. Oh, so my a value is negative 5, b value is negative 10, c value is 3. So I have negative 10. So it's negative negative 10 over 2 times negative 5. So that's going to be positive 10 over negative 10. So that's just negative 1. I'm going to plug negative 1 back in here. So negative 1 plugged in there is going to give me negative 5 plus 10 plus 3. It's 5 plus 3, which is 8. So I'm going to go negative 1, 8, which is up here. My pattern graph. So my y-intercept is going to be 0, 3 because it's in standard form. It's just that. Symmetric point, we'll get to that in a moment. So our pattern graph, if we use 1, 3, 5, we're going to multiply everything by negative 5. So I'm going to go right 1 down 5, left 1 down 5, and then go down 15. So I think you have enough here. So boom, boom. Our symmetric point is this one here. So that looks to be 2, 3. Domain negative to positive infinity. Our range is going to go from negative infinity because bottom to top to the vertex, which is 8. All right, then we want to evaluate these. So what this means is I'm going to plug 2 in for x and solve it. So that's going to give me 4 plus 10 plus 4. That's 14 plus 4, that's 18. I'll plug negative 1 into the same equation. So that's going to give me 1 minus 5 plus 4. So 1 minus 5 is negative 4. That's going to give me 0. And then we want to find, this is where we need to factor it. So I'm going to go x squared plus 5x plus 4 equals 0. So two numbers multiplied to give me 4, add to give me 5. Set those equal to 0, so I get negative 4, and x equals negative 1. Number 5, we're going to plug 0 into it, so 0, 0. So that's going to just give me negative 2. This one's going to be 2, negative 2 squared plus 7 times negative 2 minus 2. So that's 4, that's 8, minus 14 minus 2. So that's negative 6, so that comes out to negative 8. And we want to then solve this when it's equal to 5. So I'm going to go 2x squared plus 7x minus 2 equals negative 5. Let's bring the 5 over by adding it. So that's going to give me plus 3. Now it's equal to 0. So then we want to factor this. So what two numbers multiply to give me 6, add to give me 7. So that's going to give me 6 and 1. So 2x squared plus 6x plus 1x plus 3. Factor out a 2x on these. So that's going to give me x plus 3. Plus comes down, factor a 1 out of those, x plus 3. So my answers will be x equals -3 and 2x plus 1 equals 0. So subtract 1, divide by 2. And there's my solutions. Here's your quad 6 worksheet. So again, you're working this. So our A value is 2, our B value is -4, my C value is -5. So I'm going to get -4 over 2 times 2. So that's going to give you 4 over 4, which is 1. Plug this back in to get my vertex. That's going to be 1 squared, which is 2, minus 4 minus 5. So that's -7. So 1, -7. 5, 6, 7 down here. Our y-intercept is going to be 0, -5 because of that when it's in standard form. So our pattern graph is going to be 135 times 2. So I'm going to go right one up 2, left one up 2. Okay, there's my y-intercept. My symmetric point is going to be at 2, -5. My domain negative to positive infinity. Range is going to be from square bracket y component of the vertex -7 to infinity. So here's our parabola. All right, number 2, our B value, our A value is 1, B value is 8, C value is that. So I'm going to get -8 over 2 times 1, which is going to just give me -4. Plug that in to find my vertex. So that's going to give me 16 minus 32 plus 12. So that's going to give me, let's see, that's -16. So that's -4. So 4, -4. -4, -4, 1, 2, 3, 4, down, 1, 2, 3, 4, down here. Y-intercept is going to be 0, 12, so that's up here someplace. Symmetric point, we'll find out here in a little bit. All right, so I guess we can find that symmetric point. So we are over 4, so if we go over the other way, symmetric point will be -8, 12. Domain negative positive infinity. Range just opens up, so y component of the vertex. So from 4 to infinity. Our pattern graph is going to be 135, so I'm going to right one up 1, left one up 1, right one up 3, left one up 3, so on and so forth. And there's our parabola. Our axis of symmetry, so our A value is -1, our B value is -6, or C value is -6, so I'm going to get -6 over 2 times -1. So that's going to be 6 over -2, which is -3. Plug this in to get our vertex, -3 plugged in, so that's going to give me -9 plus 18 minus 6. So that's going to give me 3, so -3, 3 is right up here. Our y-intercept is going to be at 0, -6, so that's down here a bit. Our symmetric point, so if we went over, so if I went this way, so it's at -6, -6. Our domain will be negative to positive infinity. Our range, it's opening down, is going to go from -infinity to the y component of the vertex. So our pattern graph is going to be -1, -3, -5. So right one down 1, left one down 1. Right one down 3, left one down 3, so on and so forth. There's our parabola. All right, we want to evaluate each one of these, so we're going to take -1, plug it in for x. So I'm going to get 3 times -1 squared minus 2 times -1 plus 2. That's going to give me 3 plus 2 plus 2. So that's going to give me 7. Here we want to solve it when it's equal to 3. Let's subtract 3, bring it over. Multiply the first and the last, so we're getting -3. What two numbers multiply to give me -3, add to give me -2. And that's going to be 3x squared minus 3x plus 1x minus 1. So factor out a 3x, and that's going to be x minus 1. Factor out a 1, x minus 1. So my solutions on this are going to be x equals 1 and 3x plus 1 equals 0. So subtract 3, or subtract 1, divide by 3, so -1/3. Oh shoot, I didn't mean to do that. All right, for this one, we're going to plug -2 in for our x. That's going to wind up, that's going to give me +4 with a negative outside, -14 plus 8. So -18, that's going to come out to -10. This one, we want to solve it when it's equal to 0. So multiply everything by -1, excuse me. What two numbers multiply to give me 8? Add a -8, add to give me -7, so -8, +1. My answers are x equals 8 and x equals -1. And then you can watch this one in class. I think this is the last one. And then watch the volleyball one in class as well. Okay, that's good for 2 days worth of notes. Have a great day. Take care of one another.